Hello friends, I Agrawal AS, Assistant Professor in Civil Department, Sandipani Campus, Latur. Today's topic is analysis of determinate pin jointed theorem by the virtual ruler method. Now, learning outcome. A student will be able to understand the concept of virtual work and a student will be able to apply the virtual work method to find the deflection in the pin jointed frame. Now, what is the virtual work method here? Now let us consider this small pi with the bar forces caused by a unit virtual load applied at a joint and in the direction of the desired deflection. So what is your small pi? The bar forces which is developed due to the unit virtual load applied at the joint where we desire the deflection and also in the direction. And this capital Pi be the bar forces caused by the applied loading. So the bar forces small pi and this capital Pi are the constant over the whole length. So the internal virtual work of a member, individual member, that is the small d Wi is equal to Pi into the small pi into the Ei. Where is the small pi is the force and this Ei is the displacement caused by the applied load. So that becomes the here the work, internal virtual work. So here small Ei is the displacement due to applied load which is equal to a capital Pi into Li divided by the area of member into the modulus of velocity of that member, individual member. So we are putting this into here instead of the Ei. So that becomes here for the truss containing the n members, the internal virtual work expressed becomes. Now here this is for the individual. If we want to calculate the total internal virtual work for all the members, so that becomes the Wi is equal to the summation that is equal to Pi into here we are only keeping this PL by AE here in this equation. So that is capital Pi into this small capital L into the capital A into the capital E. So this is the internal virtual work for all the members for the application of the unit virtual load at the joint where we desire the deflection. Now next part is the equating this internal virtual work to the external virtual work. Now what is the external virtual work? That is equal to the 1 into delta, because we are applying here the unit load externally. So unit load into that displacement, that is the external virtual work, and here summation of this small pi into the capital P into Pi and Li, Ai, Ei is the internal virtual work. So we can say that here this delta is equal to the summation of this, again the a small p into capital P into the L divided by the Ae, and if we modify this, now again the delta is equal to a summation of pkl by Ae. Here we are only replacing the small pi with the k and rest is the same. So we can say that k is the bar forces due to the virtual force and the capital P is the bar forces due to the applied loads. So this equation, the former equation, this delta is equal to the summation small pi into capital Pi Li, these are all the equations which are taken from the basic structural analysis by the C.S. Reddy. Now this is our numeric that determine the displacement vertically at joint the C. We want here the vertical displacement at joint C. Also load is applied at the joint C, and the member having the equal area and all the members having the same modulus of elasticity. So first step is to calculate the DSI, that is the degree of static intermittency, and the formula is m plus r in bracket minus the 2j. So m is the number of member, that is the 7 here, and r is equal to 3, which as is 3r. So Ra, Re and the Ha, these are the 3 reactions, and the J is equal to the 5, that A, B, C, D and the E, these are the 5 joints. So if we put this in our equation, 7 plus 3 bracket complete minus 2 into 5, so this becomes the 0. 7 plus 3 10 and 5 into 2 is the 10. So DSI is equal to 0. Now next step is to calculate the reactions. So here we are considering sigma m is equal to 0. So clockwise positive, anti-clockwise negative. So here 10 into 3, this is the clockwise positive, and Ra into 6 is a negative. So RAE is equal to 5 kN, or by symmetry with load at center we can say that Ra is equal to the 5. Now apply sigma h condition, summation of all horizontal forces is equal to 0 to this frame. So there is no horizontal force, so we can say that HA is equal to 0. Now by the method of joint we have to analyze one by one joint. So we are considering here all the joint, but before that take up was a question in the mind of the student, that what are the different steps to analyze this frame. Now which are these steps? So what is the steps? P analysis and the K analysis. What is the P analysis? Is to find the member force due to the applied load, and the K analysis is to find the member force due to the unit virtual load. Now first step, that the P analysis. Now consider the joint E is here. So joint is here, and we are applying here the method of the joint to find the member forces. So here we are applying the sigma Fi condition. Vertically upward is positive and vertically downward is the negative. Now here member force is FDE, and we are assuming the direction is toward the joint. So now resolve this FDE in the two, horizontally and vertically. So vertically downward force is here, FDE sin 60. So here write the equation, RE is the vertically upward plus minus FDE sin 60 is the minus. So that is equal to 0. So RE is equal to 5. So we got here FDE is equal to 5.77. Then resolve this horizontally, sigma Fx is equal to 0, towards right is plus and towards left is minus. So now FCE force next, we are assuming this is away from the joint. So here apply the sigma Fx condition, horizontal force is FCE and the FDE cos 60. So FDE cos 60 is a plus and FCE is a minus. So FDE cos 60 minus FCE is equal to 0. So put here FDE is equal to 5.77 here. So we got the value of FCE is equal to 2.88. Then next go to the joint D, and we are drawing this one line which divide this angle into two equal angles, 30 degree and 30 degree. Now we are considering joint D here, and our aim is to find the member force in the CD. So first we are considering sigma Fy is equal to 0. Upward, vertically upward is positive and vertically downward is the negative. Now here FCD, we are considering the direction is away from the joint, and now resolve these forces, horizontal and vertical components here. So these are the resolution of this FCD and the FDE. So two vertical component here, that is the FCD sin cos 60, and here is FDE cos 30. So FDE cos 30 is upward, so that is a plus, and FCD cos 30 is a minus because it is downward. So FDE cos 30 minus FCD cos 30 is equal to 0. Here we know the value of FDE is 5.77. So put this here, 5.77 cos 30 minus FCD cos 30 is equal to 0. So we got here FCD is equal to 5.77 kN. Now again our aim is to resolve this joint D horizontally. So here again we are considering joint same D and resolving this as a horizontally, sigma Fx equal to 0. Again here we are considering FBD is toward the joint. Now so again resolve this, both the forces FCD and FDE as per previously here. Now the horizontal component of this FCD is the FCD sin 30 and horizontal component of FD is the FDE cos 30. So both are in the same direction but toward the left, that is why it's negative, and FD is toward the right, and that is the positive. So here FDE sin 30 minus FBD plus FCD sin 30 is equal to 0, and we are putting this value FD is equal to 5.77 and FCD is the 5.77. So here in this way put the value of this FD and FCD. So we got here FBD is equal to 5.77. So in this way we got the value of all the forces. Because this frame is a symmetric force, we can directly write here the remaining force. So this is the final diagram, final forces in all the members. So his FBD, this is the sign indicate the compression, this D indicates the compression, and AB indicates the compression, but rest of the forces indicate the tension force. Now go for the K analysis. Again our step is to find the reactions here. Sigma m is equal to 0, clockwise positive, anti-clockwise negative. Then here these are our assumed reactions initially. So 1 into 3, that is 1 is the clockwise into 3, and minus Re into 6 is anti-clockwise. So Re is equal to 0.5. So by symmetry we can say that Re is equal to 0.5. Now apply the sigma fh sigma h condition here. So we know here HA is equal to 0 because there is no horizontal force in this frame. That is why here HA becomes the 0. Then again by using the method of the joint, again we have to find the member forces due to this virtual unit load at the joint C. Again consider the joint E here. Now again resolve this joint vertically. First sigma Fy equal to 0. This is our sign convention. Vertically upward plus and vertically downward is minus. So here we are assuming this is a KD is toward the joint. So resolve this KD in the vertical and the horizontal way. So this KD is downward direction, that is why it's minus, and RE is the in upward direction is a plus. So RE minus KD sin 60 is equal to 0. So put the value of RE is 0.5. So we got here KD is equal to 0.577. Now resolve this horizontally, and we are assuming this KC is away from the joint. So resolve this horizontally. So this is the toward the left is a, as per condition is toward the left is minus, and as per condition toward the right is the plus. So KD cos 60 is the plus and KC is the minus. So KD cos 60 minus KC is equal to 0. So we know the KD value is the 0.577. So put this here. So 0.577 cos 60 minus KC is equal to 0. So KC is equal to 0.288. Now consider the joint D here. Next step. Again draw the vertical line which divide equally angle 30-30, that we know. Joint D here. We are resolving this first the vertically, and we are assuming the KCD is the away from the joint. Now resolve both these forces horizontally and vertically. So this is the resolution of this KCD and the KDE. So here KCD cos 30 is the downward and KDE cos 30 is the upward. So upward vertically is the plus and vertical downward is the negative. So KDE cos 30 is upward vertical, so it is plus, and KCD cos 30 is a minus. So we know the KD is the 0.577. So put the value 0.577 cos 30. In this way we got here KCD is equal to 0.577. Next is to resolve this joint horizontally, so that we got the value of BD. So sigma fx equal to 0, towards right is plus and towards left is the minus. So now we are considering KBD direction is toward the joint, and now resolve these two forces in the previous fashion. So horizontal forces are the three: KD sin 30, then KDE KCD sin 30, KDE sin 30 and the KBD. As per sign convention, towards right is plus and towards left is the plus. So as per sign convention, this equation is KDE sin 30 minus KBD plus KCD sin 30. We know the value of KDE here also and KCD also. So put the value of KBD, KDE and the KCD. So we got here the KBD is equal to 0.577. So by symmetry we can write the AB force, then BC force and the AC force. So this is where the forces developed in the bars due to the unit virtual load at the joint where we desire the deflection. Now, next step is the prepare the table. Now this is the table where vertical displacement at the joint C. Now these are the all are the members A, B, B, D, D, A, C, C, B, C and the T. And we are considering the area as the A. So that is in the meter square A, and all the having the length the same, that is the 3 meter. And these are the bar forces due to the applied load, that is the P. The member AB 5.77, member BD 5.77, member D 5.77, member AC is minus 2.88 because here we are considering the tension as the negative. So here AC members is subjected to tension, C member also subjected to tension, BC member also subjected to tension, and CD member also subjected to tension, that is why is a negative. And the next column is the K forces. These are the due to the unit virtual load. So forces in the member due to the unit virtual load. These are the column at 0.577, 0.5577, 0.577. Then again the minus 0.288, again minus 0.288, again minus 0.577 and minus 0.577. Minus means the tension and the plus means the compression. Now the last column that we know here, PKL by the AE. P is the force developed in the member due to applied load, and this K is the member force developed in the member due to the unit virtual load. Length is the individual length, and A is the area, and E is the modulus of elasticity. Now here A and the E is the constant for the all the members. So here P is the for first column. Here P is the 5.77 into 0.577, length is the 3. So that becomes 9.98 divided by the AE. So these three values are the same. So same are the three rows. The next is the what? P is the minus 2.88. So minus 2.88 into the minus 0.288 into the length. So that becomes here minus minus plus. So 0.83 by the AE. In the same way here the 2 row here. Then the last 2 row again here the force is the minus. Also the both the forces are the minus. So minus 5.77 into minus 0.577 into the 3. That become minus minus plus. So 9.98. So summation of all this here is the delta C is the vertical displacement at the joint C, that is equal to summation of sigma PKL by AE, that is equal to 51.56 divided by AE in the meter. This is the deflection at the joint C. Thank you.